Good morning, students. Exercise 7.3, the problem number 6. A race car driver is racing at 20th kilometer. If his speed never exceeds 150 kilometer per hour, what is the maximum distance he can cover in the next 2 hours? Okay. See, the race car driver is racing at 20th kilometer. So, the 20th kilometer he starts his race. Okay, the speed he maintains is never exceeds 150 kilometer per hour. So here I have taken y is the function of t. T is a time. Okay, y is the function of t. Y is nothing but the distance at any time t, the distance covered by the car at any time t. Okay, so given that, see, the starting is 20th kilometer. He starts at 20th kilometer. So f of a, the time I have taken as a, so f of a is equal to 20. So 20 is the distance, so therefore we can write f of t. So here I have taken f of a is equal to 20. And what is speed? So speed is nothing but never exceeds 150 kilometer. See, f of t is the distance means, so speed, it's derivative. So x is the distance means dx by dt is nothing but the velocity or speed. So therefore f dash of t is less than or equal to 150. So what we have to find, what is the maximum distance? Distance is asked. Distance is nothing but f of t. So he can cover in the next 2 hours. So starting as a and the next 2 hours means I have taken as a plus 2. So distance is asked. So f of a plus 2 we have to find out. Okay. So we know that your function distance is a continuous function in the closed interval a comma a plus 2, and f of t is, that function is differentiable in the open interval a comma a plus 2. So we are going to use the mean value theorem. So that is what f dash of c is equal to f of b minus f of a divided by b minus a. So f dash of c is equal to, what is your b here, a plus 2 minus f of a divided by b. In the place of b you have to substitute a plus 2 minus a. So here next one, f dash of c is equal to f of a plus 2. What is f of a? We have taken, it is 20. Okay, divided by 2. This 2 we can cross multiply. 2 into f dash of c is equal to f of a plus 2 minus 20. The minus 20, when you bring it to here, it is plus 20. That is equal to f of a plus 2. This only we have to find. F dash of c is less than or equal to 150. So here I have written 150. So it has to be written as is greater than or equal to f of a plus 2. So 2 into 150 is 300 plus 20 is greater than or equal to f of a plus 2. Okay, so f of a plus 2, if you write first, does the sharp end has to come here. So f of a plus 2 is less than or equal to 320. So the maximum distance that he can cover in the next 2 hours or the 320 kilometer. Okay, it is less than or equal to 320. So the maximum distance is 320 kilometers. So we'll come to the problem number 7. Suppose that for a function f of x, f dash of x is less than or equal to 1 for all 1 less than or equal to x less than or equal to 4. Show that f of 4 minus f of 1 is less than or equal to 3. Okay, so first it is given f dash of x is less than or equal to 1 for all 1 less than or equal to x less than or equal to 4. When x varies from 1 to 4, f dash of x is less than or equal to 1. So it reveals that the function is differentiable in the closed interval 1 comma 4. Differentiability we can check only the open interval, but it is given differentiable on the closed interval 1 comma 4. So we know that every differentiable function is continuous. So therefore, here the function is differentiable in this closed interval. So therefore, it is continuous on the closed interval. So the Lagrange's mean value theorem is satisfied. So we can write f dash of c is equal to f of b minus f of a divided by b minus a, where c belongs to the open interval 1 comma 4. Okay, so f of b is what here in this interval? So b is 4. So f of 4 minus a is 1. F of 1 divided by 4 minus 1. So f dash of c is equal to f of 4 minus f of 1 divided by 4 minus 1 is 3. So 3 when you cross multiply, it is 3 f dash of c is equal to f of 4 minus f of 1. So f dash of x is less than or equal to 1 for all x varies from 1 to 4. Here you will see also in the open interval 1 comma 4. So we can use it is less than f dash of x is less than or equal to 1. So in the place of f dash of c you can substitute 1. So you have to use a symbol is greater than or equal to f of 4 minus f of 1. You see that the one place f dash of x is less than or equal to 1. So if we substitute here 1, it has to be written greater than or equal to f of 4 minus f of 1. So if you write this as first, f of 4 minus f of 1 is less than or equal to 3. So what is that? F of 4 minus f of 1 is less than or equal to 3. That is the result we have to find. So come to the problem number 8. Does there exists a differentiable function f of x such that f of 0 is equal to minus 1, f of 2 is equal to 4 and f dash of x less than or equal to 2 for all x. Justify your answer. So here we are going to use the mean value theorem. So here it is given f dash of x is less than or equal to 2 for all x. So it is differentiable. Every differentiable function is continuous. Okay, so we'll go for f dash of c is equal to f of b minus f of a divided by b minus a, where your c belongs to the open interval 0 comma 2, because f of 0 is minus 1, f of 2 is equal to 4. So 0 in the interval is given 0, lower end is 0 and the upper end is 2. So c belongs to the open interval 0 comma 2. F dash of c is equal to, in the place of b, f of 2 minus, in the place of a, 0 is substituted. So f of 0 divided by 2 minus 0. What is given? F of 2 is 4 minus in between. F of 0 is minus 1. So 4 plus 1 by 2. Okay. What is it? 4 plus 1 by 2. It is 5 by 2. That is equal to 2.5. So when you use mean value theorem, your f dash of c is equal to 2.5. But what is given? Your f dash of x less than or equal to 2 for all x. So f dash of x is less than or equal to 2. Maximum value is 2. But here we have found it is 2.5. So therefore, with the given condition, your f of x does not exist. The next one, ninth problem. Show that there lies a point on the curve f of x is equal to x into x plus 3 e power minus pi by 2 minus 3 less than or equal to x less than or equal to 0, where the tangent is parallel to x axis. If the tangent is parallel to x axis, we have to show that the tangent is parallel to x axis means you have to show your f dash of x is equal to 0. Okay. So see now, first we consider f of x. So here I just multiplied. So x into x plus 3 e power minus pi by 2. X into x is x squared. X into 3x is, x into 3 is 3x. X squared plus 3x e power minus pi by 2. So this function is continuous. The closed interval minus 3 comma 0, and it is differentiable on the open interval minus 3 comma 0. By the mean value theorem, f dash of c is equal to f of b minus f of a divided by b minus a, where c belongs to the open interval minus 3 comma 0. So f dash of c, that is equal to, in the place of b you have to substitute what? 0. So f of 0 minus, in the place of a So minus 3 is substituted. So b is 0 and minus of a is minus 3. So minus of minus 3. So here we have to find out f of 0. So f of 0 means go to f of x and substitute x as 0. So 0 plus 3 into 0 is 0. 0 into e power minus pi by 2 is 0. And if we substitute f of minus 3 here, so minus 3 the whole squared is here, plus 3 into minus 3 e power minus pi by 2. Minus 3 the whole squared is 9. 9 minus 9 e power minus pi by 2. So the answer is 0. Okay, so you come to f dash of c. So that is in the new, this value 0 minus 0 divided by 3. So the answer is 0. So f dash of c is equal to 0 means the tangent drawn at c is parallel to x-axis because the slope is equal to 0. If the slope is equal to 0 means the tangent drawn at c is parallel to x-axis. So we have proved there lies a point on the curve where the tangent is parallel to x-axis. Okay, so we'll come to the problem number 10. That is, using the mean value theorem, prove that for a is greater than 0 and b is greater than 0, modulus of e power minus a minus e power minus b is less than modulus of a minus b. Okay, so first here the no function is given, so we have to take our function. So here e power minus a, e power minus b is involved, so we have taken the function f of x as e power minus x for the function, be the function. Okay, so this function you know very well, it is continuous in the closed interval a comma b and it is differentiable on the open interval a comma b. So we have to use the mean value theorem, Lagrange's mean value theorem. So f dash of c is equal to f of b minus f of a divided by b minus a, where c belongs to the open interval a comma b. So first you consider the left side, f dash of c. So for that you have to differentiate the function. So f of x, if you differentiate, it is f dash of x. E power minus x, if you differentiate, minus e power minus x. So go for f of b. So in f of x you have to substitute x as b. So it is e power minus b. Next f of a, that is e power minus a. So when you substitute this result, here in the place of x you have to substitute c. So what is f dash of c? So it is minus e power minus c, which is equal to e power minus b minus e power minus a divided by b minus a. And you know that this value whose modulus is less than 1, because in the answer, the question they have given, the answer is in terms of the modulus. So you know very well this modulus exponential function, adu negative modulus of minus e power minus a is less than 1. So therefore this value is less than 1. So modulus we can apply the numerator as well as the denominator. So modulus of e power minus b minus e power minus a divided by modulus of b minus a is less than 1. So if we take minus out, because in the question here for starting is e power minus a, but we have written e power minus b. So from the numerator we have to take minus out. If we take minus out, it is minus is taken out means e power minus a minus e power minus b. So here I have written. In the same way in the denominator, here you are having b minus a. If we take minus out, it is a minus b. Okay, so modulus of minus is nothing but modulus of e power minus a minus e power minus b. And this also can be written as modulus of a minus b is less than 1. So bring this term to the right side. So modulus of e power minus a minus e power minus b is less than modulus of a minus b. Thank you, students.